Hey guys, welcome to another Battery Monday. My name is Zach, and today's topic will be focusing on maintaining your lithium battery, specifically storing your lithium polymer batteries. Now, lithium polymer batteries are widely used in wearable products, drones, the radio control hobby industry, industrial equipment, cell phones, laptops, and even more. So over the years, lithium batteries have integrated themselves in our everyday lives. As such, it's vital to understand safe usage of lithium polymers, especially so that you can avoid any accidents, any fires, or even early product failure. Here's a good rule of thumb if you don't plan on using your lithium polymer powered devices for a while. For a battery that's removable, you should discharge the battery down to about the halfway mark, or if there's no external fuel gauge, then down to storage voltage of 3.8 to 3.85 volts per cell. For an integrated battery that's not removable, you can leave it fully charged, as the BMS board in your device will manage the battery. But remember, because the battery is being monitored and managed, there will be a small load on the battery even if the device is off. Make sure you check on the device regularly to ensure that the voltage doesn't drop too low. And we've said this many times now in our Battery Mondays, but the maximum charging cutoff voltage of a regular lithium polymer battery is 4.2 volts per cell, while a lithium high voltage can go up to 4.35, 4.4, or even 4.45 volts per cell. If you leave your battery at maximum voltage, you run the risk of decreasing the battery's lifespan and causing your battery to swell. Now, temperature plays a large role on battery storage. The ideal temperature for storing your battery is 70 degrees Fahrenheit or 21 degrees Celsius. Don't let the room temperature get too cold or too hot. Low temperatures will cause the electrolytes to freeze, reduce the internal resistance, and may form lithium condensation at the cathode, causing irreversible effects. And high temperature can accelerate some chemical reactions inside the cell to form gas, shorten the battery life, and seriously cause thermal runaway, fires, and even explosions. The side reaction products also accumulate on a negative surface, which causes a significant increase in the impedance of the SEI film. Well, that's all for today. If you have any questions about today's topic or any battery-related things that you want to know, you can contact us by email at info@grepow.com. Until then, my name is Zach, and thank you for watching.